Okay, what's up and welcome back to the channel. This is the Prokon Geek, and in today's video I'm gonna show you how to quickly design a flash slab using Prokon, or rather let me just get you started on the whole flash slab design series. So without wasting too much time, let's just get right into the video. Okay, so like I told you in the introduction, today we need to get started on flash slabs. So it's a question that I had from the beginning of the channel. Someone requested for me to do a flash slab, then someone, and the list goes on. So what I decided is, you know what, let me try and get a quick video where I just show you some of the basics of how to design a flash slab in Prokon. But one thing that I need to warn you before we go forward is, this is the thing, whether you're using Prokon or any software, you need to understand the software and the theory behind the design before you even attempt to do what it will. So in this case, I don't want to do too much of a theory, but I'll try to explain the flash slab design theory as well in a series of steps that will lead up to entering the data in Prokon. And you also find that software will always give you an answer even if you put something that you don't know. And there are some aspects that you need to understand the theory behind this, so that when it comes to a section like this where you need to put the reinforcement for a flash slab, you understand what they mean by 75, 55, 2000, 2500, because you don't just pull these numbers from where the sun doesn't shine. No, you need to know where these numbers are coming from, and you need to figure out what you're doing. So not to waste too much time, this was the introduction. Let's just move into AutoCAD and get started before we come back into Prokon. So this is what's going to happen in AutoCAD. I'd already had a slab layout, a flash slab layout, and I had done the steps already for you guys, and also because I don't want to forget what I need to do as I'll be doing these steps. So to get started, what I'll just do is let me delete this and let's start fresh and let's look at the layout that we have. So normally, typically, I don't want to do things that you do not do in real life or textbook material. I do real life project material so that you can understand how to apply these things when you go out into the real world when you finish your college. Right now, so this is what's happening. Normally in the previous videos that we did, I have a series where I designed another double-story building, and in this series we had a building that was supported by slabs, which was a normal slab which had monolithic beams and which were downstream beams, and these ones connect into the columns, and that is how the load transfer occurs. You got the slabs, then it goes to the beams, and then it goes to the columns. But in this case, or for a flash slab case, you don't have any beams. All you have are the columns connecting straight into the slab. So your load transfer will be basically just from the slab and straight to your columns down to the foundations, because you don't have any beams to support this. So it becomes a bit of a challenge, because when we were designing this other slab, it's quite easy. All you gotta know is how are you doing this? Well, the slab, you can analyze it in any way, or you can just use Prokons. Let me see, if you go to Prokon, there you have the slab module where you can design the rectangular panel design. So this one, you can use it even for a simple in this case, for our building, you could have used that one for each of the different panels, and it would have been okay for you. But now, in a situation where you have a flash slab, that is now different, because the conditions you have for this module, right, this slab module is different for the conditions that are needed or that you have for a flash slab. So that is why you come up and use this module, which one they call the continuous beams or slab module, and that is the one that you need to design. But you need to understand what you need to key in first. So as I was saying, you have your layout, right, cleaned up, everything is good. The blue indicates the edge of the slab, then you got your grid lines in magenta, right, and your dimension lines, and you're good to go. So the first thing that you want to do when you get a flash slab and you have a layout, right, what you want to do, sorry about that, is the first step is to establish what we call the midpoint. So to go along with me, what I'm going to do is, let me just copy this, then go to this point, right, then I'm just gonna say snap to this point, then carry, so that it is uniform. I try to do this so that you guys can follow along to all this point that we're gonna do. So the first step that we need to do is called establishing the midpoint. I already done it before, but now we're doing it together. So to establish the midpoint, what you need to do is you go to the distance and see the distance between your supports. And in this case, for a slab, the supports are the columns, right? So in this case, the distance between this is 5,000, and luckily for us, it's 5,000 throughout in this direction, and also 5,000 in this other direction, right? Remember, we got a 20 by 10 meter building or slab, and that is what we're going to be working with. So to work with this, normally, you would want to go to the midpoint, create a line there, then create a line there. Then what you would do is go to the midpoint, then go all the way down there, and then what you would do is try to make this gray. So in this case, since I already done it, all you have to do is just match the properties, right? And this is what you would normally, this is how you would normally do it if you were start. But luckily for us, this is 5,000, it's uniform, so it's as easy as just offsetting the grid lines by 2,500, like this. Let me show you. All right, that is great. So offset this one as well, then offset this one. Then all you gotta do, so that you're not confused, is to match the properties. Then you establish your midpoints, and there you go. You've established your midpoints on your slab, and you're good to go. Then you also need to establish the midpoints in this other direction. So still 2,500, offset it to this point, offset it to this point. Then you MA, matching the properties. Right, then you're good to go. There you have established the midpoints. Now, why do we establish the midpoints? We establish the midpoint because it's critical for step 3, which is divided into 2, where you establish what we call slab strips, LY and LX. So this is a bit of the theory, but I'm doing it in a step, so we don't want to waste too much time going into fluffing around. So we design, this is what we do. This, I'm just trying to teach you steps. So now what you gotta do is establish what we call the slab strips, right? Instead of me having to type, I can always just copy this. Let me copy this one as well, so that we already have it before we mess up anything. All right, now we go and then we put it there, and we good. So the first part we need to do is establish the slab strip in the LY. So this is LY and this is LX. So to establish in the LY, what we are doing, just watch me do it. This is what you're going to do. The first strip that you're going to do is you're going to establish H, this point. I'm just showing you which one is called the first slab strip. Then you want to change this, go to anti, then change this to about 50, and you're good to go. So this is what you've done. You've successfully established the first slab strip. So what we do is we'll just say tap, then F8 to make sure that it's this, and then we're gonna call this strip 1. So this is gonna be strip, or we can call it strip A, right? We're not talking about strippers, by the way. Then HA, what you're gonna do, you just want to repeat, then you're gonna do it to the other side as well, and there you go. This is the second slab strip. This time around, change the color. Then maybe you want to go with green. Green looks good. Then 50 to do it like that. Change the angle to 50. Then select anti. Well, this green is a bit too dark. We want things to be colorful so that you're able to see. And there you have established the second strip, right? Actually, what I'm going to do is, let me just do this. Let me copy this and put it down there. And what we're going to do, this is what we're going to call it. Let's call it strip B. But what I'm going to do is, now you see this remaining part. All of this is going to be strip A now. So what I'm just going to do, let me put this to strip A, because I'll show you why I'm doing this later on, you understand. And then this one we'll just call this strip C. Okay, and this is strip A, and then what you do is just HA. All right, you establish it now. Okay, there you go. All right, next thing that you want to do, select the color down, just it's anti-41. Then what you can do is 45, make it 45. Okay, 45 doesn't work, let's just put it at 90. Then we're going to change the color and we're going to make it white. Right, so this becomes strip A. So one thing you need to note whilst you're at it is, this is what's happening. Let me just annotate to show you. Strip C is going to be 2.5 wide, and strip, actually I should have started this one as well. So strip B as well is also going to be 2,500, and then strip A which is the first strip, which is going to be the first. The reason why is was that's the first strip that we're going to design. Is going to be 5,000. Then once you have done this, you've established your main strips in the LY. Next, go to the LX. So to the LX, it's quite easy. This is what you just want to know. I think you have picked up the pattern from now. You always want to start off from the edges. This is what happens, right? Then chop, chop, chop. Right, so this time we got a cool thing. I'm gonna MA because we already there, and change it to this. That looks good. Then we're gonna edge A, but now take good note of what's happening now in the LX. This is what I'm doing. This is how you're establishing the slab strip. This is one slab strip, right? This is another slab strip, and just remember, in this case, the color does indicate the difference, right? So this just MA to match properties. Get this match properties, then you get back, then you come to this point. Then the next thing that you want to do is now HA and create. You're now creating the last slab strip. So the only reason the other ones, you in this case you got 2 green ones and 2 orange ones, I'm just doing it because you will find they're identical, right? The outer edge, yes, in this case these other ones were identical, but I just wanted you to sort of have an idea. But in this case, if we design for this green one, we design for this orange one, you're good to go. And in this case, it's the same. If you design for strip C, you design for strip B, but we're just gonna do it differently so that at least it's fun. You get more entertainment or more knowledge that way. So in this case, what we're gonna do is we're just gonna copy this to show that you're establishing your slab strips. And yes, I am just recording this as well, fast, or should I say sort of in a live way. So that is why we have the background music going on. Right, so strip B, so strip C, this we're gonna call it strip B, and we're gonna call this strip A. Alright, so this is gonna be the background of what we did. And once you've done this, you've established the slab strips and you're good to go. So you've established the strip in the LY and the OX, and the next thing we now need to do is the next step is to isolate the central strip. So don't worry, we are going to isolate each strip and design for each strip. That is to say, that is the theory, that is what you're doing. You need to understand when you're analyzing flash slabs, you analyze them in strips. So you need to understand, you need to create what we call slab strips, right? So you understand the theory much more when I do more videos on this, but at least for now you understand what happens. So let's just recap. You get your layout, then you establish your midpoints, then you establish the slab strips in the LY and in the LX. Now you need to isolate the central strip. So that is easy as you can just copy this one, right? Go there. This is what you normally do. Even when you're like other guys do it using hand calculations, I just love doing it in AutoCAD, right? I'm used to, although you find even there's still guys, you know, I might call myself new school a bit, guys in the late 20s and early 30s who still do hand calculations, but you know, but I think most guys in the 20s or early 20s, you guys use AutoCAD like I do. So I'm kind of new school as you, right? Then this is what you have. So you've isolated your central strip, and this you have to forget about it. So you just have to remove this so that this doesn't distract you, and also this doesn't distract you, and you're left with this central strip. And then what you just need to take note of is that this central strip in this position it's 2,500, and in this direction as well is 2,500. Then just put that and note that down. Then you can also just remove this ones because they're not important, the 5,000 and this 5,000, right? Once you remove that, what you just want to know is that you do have a central strip that is 5,000 wide. So now once you have this answers the question. The first question that you need to understand is when you come to Prokon asks you what is your section going to be. So obviously you remember, you come to Prokon, you enter 1, and in this case you already know what the section of your web will be, 5,000. Now I hope you understand where the 5,000 is coming from. When we are going to be doing strip C and strip B, this will need to change from 5,000 to 2,500 to confirm. So in this case, it's going to be 5,000. We good like that. Let's go back to AutoCAD. All right. Now that you've isolated the central strip, you now need to do what we call establishing the column and the middle strip. So you do this for that central strip. So copy this, right? Then get it to this point. Remember, first thing, isolate the central strip. Then once you do that, go to what you want to do is establish the column and the middle strips. So this is what you do. You come there, then you go to this point, and then you see what is the distance. In this case, it's 2,500. So what you're going to do is you're just going to offset this point by half the distance. In this case, half of 2,500 is 1,250. So let me just offset it by 1,250. That is good. There we go. Then you do to the same side. In this case, you find again it's 2,500. So you just offset this by 1,250. Then what you want to do is just want to make these lines red. So in this case, instead of wasting my time, what I'm just going to do is I'm going to come up there. I already done it. What we can do is make the central ones out red, right? So just to isolate that this is the whole central strip, and then the ones in the middle, since they are midpoints, you just make them gray. So this is what you've done. Or what you can do is just make them yellow like this. Let's make them yellow like that. Then what you're gonna do is remove this hatch, and now I'll show you. This is strip A in its entirety. It is strip A. So this is what I'm gonna do, show you that this is strip A. This is what you gotta do. So in this entirety, this is strip A, and just to change that, let's go there so that you don't forget that this is strip A. This is strip A. So this is what I'll do is I'll call it slab strip A. As you can see, this indicates all of this is slab strip A. But in the slab strip, we need to establish what we call a middle strip and a column strip. So let's establish the column strip first. So the column strip, basically, as it says, is the strip that is closest or interference, has a greatest interference with your columns. So let me just show you what they call the column strip after you've established your slab strip. In this case, whatever I am hatching right now is what we call the column strip. So this is what they call the column strip. So let me just remove this 5,000, right? And let me show you what they call the column strip. So in this case, from this point to this point is what you now call the column strip. And let's go there and let's annotate it so that you understand what we call the column strip. Showing people how to design a flat slab in AutoCAD. Who thought this could be done? All right, so this time, to make it more visible so that you don't get boxed, we're just gonna box this, and let's put it pink or whatever color that is. I'm not good with colors, and we're just gonna put this with 50. Man, not good with colors. I think that's true. There we go. Then we're just gonna put that at 45. All right, and there you go. There you have it. Now this is what we call the column strip. Okay, I think this color is a bit funny, so we're just gonna change it to something else that I think, let's just put it green for now. Then next you need to establish what we call the middle strips. So in this case, instead of me having to annotate them like that, what I'm gonna do is I'm just gonna copy this. Okay, right now there we go. This is gonna be the middle strip, and there you go. This is gonna say this is the middle strip. There you go. You got the middle strip there. Then you're gonna copy it again. All right, there you go. So this is what are gonna be your middle strips. I'll show you the reason better mostly when we are done. But let me show you that HA. This is what you do. This is the middle strip. This is what they call the middle strip. Then you establish your middle strip. There you go, and you can just make it the same because it's basically just one and the same. And let's make it angled again. Then we're just gonna make it 45, and the color we're just gonna make it, let's make it, okay, let's keep it like that. And then we're gonna pump this to 50. All right, so there you go. You have established the orange ones are your middle strips, and the green one is your column strip. So that is one of the most important things that you need to know and to define for yourself. So once you have done this, you're good, and you just need to know, that's the other thing, you need to know the distance or the width of this column strip. So in our case, the column strip is going to be 2,500. Remove this 5,000, you don't need it anymore, right? And there we go. The middle strap, this one is going to be 1250, and there we go, 1250. Now you're good to go, right? You have your column strip, you have your middle strip. Then the next step that you need to do is you need now to take note of your span, and remember, it's a two-way span in slab in theory. So what this just means, I don't really need, so okay, the best way to visualize what I mean by take note of your span, instead of me just having to copy the drawing that's at the top, let's copy this one, right? Then there's F8, right? Then it snaps. So this is the original layout. So what do they mean by a panel? Or take note of, so for you to take note of the span, you need to understand which ones are the panels. So in this case, what I've just labeled in red, so I'm just, but at least for the line work, I'm just gonna copy from above, right? This is a panel. This whole entire thing, let me just say, from this to this point, this is the bay, right? This is the entire, but then it's divided in this case into 8 panels, and these panels are the ones that I am showing you. This, you need to take note which ones are your panels, but in this case I can just copy this, right? This is what you will be doing, just telling yourself, oh, this is my panel. Okay, man. Whoa. So these are your spans, right? These are your panels. This is what you want to do. And then what is the span of each panel? In this case, we have identical panels, so we are good to go. We don't have to worry too much. Then what you just need to know is, okay, what is the span in the LY? In the LY, it's gonna be 5,000. Wow, really? That's what you ask yourself, and you're like, yeah, man, it's 5,000. Then in the LX, right? The LX of the bay. What is the span? Oh my gosh, it is still 5,000. Oh my gosh. Okay, so that's what you need to do. So the span is still 5,000. Why is this important? Because the next step that you need to do after, let's have a recap. Start off with your layout, establish the midpoints. Then what you do, establish the slab strips, right? LX and LY. Then isolate the central strip. Establish the column and middle strip. Take note of your span, and remember it's a two-way span. The reason why is because the next step is you need to calculate the depth of the slab that is required in MathCAD. Why am I saying that in MathCAD? Because I use MathCAD, remember? So what you're gonna do is, I think I have my sheet. I'm just gonna say slab depth. Then I go to slab depth, okay? And in this case, provide the short span of the slab. And since we have it's equal, so we're just gonna put, if the short span is also equal to the long span, which is good for us, but we're still going to put 5,000, which is okay. Then provide the span over depth limiting factor. So which one are you going to use in this case? Some people will be asking. So the first thing that you need to understand, whether you're using SANS or BS, remember SANS came from BS. The tables that you use are the same tables that you use when you are using for beams. In this case, if you're using SANS, this is the table. This is taken from table 10 of SANS. Okay, table 10 in SANS 10:1 gives this basic span over D ratios for rectangular beams with a span of less than 10 meters. And now some people are gonna be asking me, but Prokon Geek, this is for beams. Yo, let me tell you something. You use the same table for beams or slabs. Prokon Geek, you're lying to us. Okay, let me just show you, because you think I might be lying to you, but I'm telling you, you use the same. So remember, this is module 4. We are now under slabs. Let's go to where they talk about deflection in slabs. All right, this is deflection. Check. What does it say? SANS 10100-1 states that it will be sufficient to restrict the span to effective depth ratio. Table 10. Which one is table 10? Let me go. Check. Table 10 in SANS. So you see, I'm not, even if you're using BS, let me just show you, because people think I'm a liar. I'm joking. People don't think I'm a liar, but I just want to show. Deflections in slabs may be calculated. Okay, this is under slabs. So people may be asking, where does it say deflection slabs? We are under slabs, shear resistance solid slabs. We're under slabs. deflection may be calculated and compared with serviceability requirements given in section 3 of BS. What in all normal cases, the appropriate ratio may be obtained from table 3.9 modified by table 3.10. Now let's go to table 3.9 and let's see what does it say. Because that's the thing, people say, which code are you using? What do you get these figures? You getting them from where the sun doesn't shine? My friend, I do not. Anyways, table 3.9 says basic span over effective depth ratio for rectangular or flanged beams. So that is one thing you need to know. You use the same table whether you're going with beams or you're going with slabs. In our case, the rectangular section, right, is saying cantilever, simply supported, or continuous, and we know our slab is continuous, so we're going with 26, right? That is what I want to do. I want to use 26, right? And in this case, you could use 24 or you could use 28. In my case, I'm just gonna go with a BS, which gives me a central figure, which is 26, right? Which is okay. And also the AC has different things, but then we're just calculating the depth of the slab. So what you're gonna do is you enter 5,000, then you give it 26. Then what does it do? It calculates D from LX over X, but make it subject to the formula. Therefore, D is equals to 0.192 meters, and the overall depth of the slab is D plus 30 millimeters, giving you 0.222 millimeters. But you know what I'm gonna do? I'm just gonna round it off because I'm the best person that you ever know, and I like doing the slabs. Okay, so what I'm gonna do is the depth. Now I know it. What I'm just gonna do, I'm just gonna round it off to 250 millimeters, because let's be honest, who is going to use 222 to 2? That is just a difficult thing to use. Okay, now we have the section. We're able to define the section. Now you know where 5,000 and 250 are coming from. Now, what is the next thing that you want to do? I've already calculated the depth. Then the next thing after you do that, you calculate depth, you now need to go to Prokon. So we're going to go to Prokon. So now, yes, we're there. The music has stopped. I think we need to just replay it again so that we start back. Now, this is Prokon, and we are now in Prokon. So what are we going to do? We're just going to name our slab. So in this case, we're going to say this is strip A. We're going to say this is strip A. Right, this is strip A, and the FCU, what are we going to use? In this case, I think I'm just going to use 25, right? Then the FY, 25. Why am I using 25? Because most people are able to make 25, especially when you're dealing with non-professional or not the best contractors out there. You want to stick to 25. Then the next thing you want to do is you want to use 450. Then FYV is going to be 250. That is for your links. So this is for your main reinforcement, right? You could use 450 or you can use 460. The code does say 460 if you're using BS, but 450 is what is normally is an empirical value. Most steel out there is 450. 460 is the idealized. So in this case, I'm just going to use the empirical 450. Then FYV is going to be 250. In later codes, and actually the BS, the theoretical or the idealized is now 500. But I'll tell you, if you're getting Chinese steel, it's not really 400 or 500 most of the times, unless you test it. But most of the times, I'm just saying. Now, are we going to redistribute? No, because we want a more accurate situation of what's going to happen at the supports, and also just because we don't want to redistribute the steel, it slabs as opposed to beams. Now, the cover to the center or the top of the steel. In this case, I'm going to have a cover to links, or what I would say a cover to links. I would want 40. Then I'm going to 30. I mean, then let's just assume my slab is going to take 120 bars. I'm just assuming. You need to assume. You need to come from an assumption somewhere. So the depth to the center of the steel will be 20. That is the top layer, and the bottom layers will also be 20. So half it will be 30 plus 10, because the diameter is 20. So if you half it, so you're saying the cover is 30 plus half the distance to the center of the steel, so that will be 40. So cover to center of top steel will be 40. 30 plus 10. Next, dead load factor. What code do we need to use? Okay, let's just go with BS for now. So we're going to use 1.4. you know 1.2 is for sands. Then the live load factor is going to be 1.6. Density of concrete is going to be 24, which is okay. Next, what are we going to do? Everything else seems fine. 25% of your live load will be considered permanent, which is okay with. Next, you go to the sections. In this case, we already did the sections and you know where B, W, and D came from. Next, you want to go to your spans. In this case, right, in our case, what is the length of all our spans? Since we're dealing with the central strip, this is going to be 5,000, 5,000, 5,000, and 5,000. Okay, so 5 meters. And if you want, you can control C and control V, control V, control V, and you're good to go. Next, what you're going to do is you want to go to your supports. Now, what type of supports do you have? In this case, what we want to do is let's mirror actually what type of support, how long out is this column. So it's a 230 column. So what you want to do is the depth, this one becomes 230, and remember this one becomes 300. But you say, where did you get that, Prokon Geek? Okay, let me show you. I love you very much, so I'm going to show you. It's 300, as you can see. So what you're going to do is you're going to go back. Let's just copy this. Control C, Control V, 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 Control V. Now you're good to go. All right, so some of you will be asking, do we have columns at the top? So in a normal case, you usually have columns at the top. That's how you want to model it. But if you really want, or you're afraid of design, right, or you're a newbie, or you want to be conservative, they say it's being called being conservative. What you do is you model is as if it's simply supported like this. This is how you do it, because what happens is columns also carry the moments, also help to lessen the moment that is occurring in the slabs. So when you put it simply supported, all the moment will be in the slab, and that is what it will kind of require more steel. So if you want to be conservative, that's what you will do. And since you're a beginner, this is what I'm going to start off with you. Then the next thing we want to do is put our loads. So you already know we have 4 spans when we need. So where is the dead load going to come from? The dead load is going to come from the unit weight of the slab and maybe some finishes that will be there. So what are we going to do? Let me take my calculator, or let me just put an Excel file. Let me put an Excel file. Let me put Excel. Oh, I already have Excel open. Thank you. Okay. This is the column. You remember the column take down load sheet? We're just going to have a new sheet. Then we're just going to say blank workbook. So what we want to do is we want to calculate the dead load from the slab. So the dead load from the slab, what you need to know is it could be the thickness of your slab. In this case, the slab is going to be 250 millimeters thick. Then are we going to have any finishings? So we're going to assume a screed of 50 millimeters, right? Then once you do that, total thickness in this case, or what we're going to do is this weight, unit weight of concrete. So unit gamma of concrete, that is what you're going to do. Then you want to wrap the text. Unit weight of concrete, this one is going to be 24. Then control C, then control V. Then this is going to be the unit weight of the screed, and in this case this one can be 24 or 23 depending on the different codes. So what is the unit weight of the load that is going to happen? So in this case you're going to say, remember this is 24 kilonewtons. So what you will do is divide this by 1000 so that it's in meters, remember. Okay, all right, so let me just remove this, and that is 0.25. And let's just put, instead of having to divide this, let's just put 0.5 like this. So what you're gonna do is, this is the slab load, right? And then this is the screed load. This is how you'll be doing it. So the slab load will be equal to 0.25 multiplied by 24, and in this case this will be 6 kilonewtons per square meter. And then the screed load will be this multiplied by 23, and what you get, wait, now there's a problem. Now I know why it's 0.05, because I was surprised, how could the screed weigh more than the concrete? That is something that you also need to take. So the total dead load in this case will be this plus that, and you have 7.15, and let's just assume some services of maybe 0.5, so we're just gonna bump it up to 7.5. So control C, control V, control V, control V. So that is gonna be the dead load. But what about the live load? Is it gonna be 25? No, man, it's not gonna be 25. All right. Oh, wait a minute. This is what's happening. I was about to give you the wrong notion. So what's happening is, this is the kilonewtons per square meter, or 7.15 per square meter. But what you're gonna do is, you know the length of your column strip, and the length of your column strip is 5,000. So what you're going to do is go back to Excel, then you're going to say length, or in this case it's going to be LX, just put LX, and in our case it's going to be 5 meters. So load per meter is going to be, forgive me for that little mistake, so, or that little transmission that was about to happen. So what you're going to do is say 0.5 multiplied by 5, and in this case it's going to be 37.5. so what you're going to do is, you want to come there, oh wait, you're going to go to Prokon, so it's going to be 37.5, right? Then you drop it there, then you drop it there, then you drop it there, 37.5. Now what is the next thing that you need to do? The next thing that you need to do is now go in and check whether what is the live load. So remember, with the live load, we're just gonna go to our code, and in this case, dead and imposed load. What are we gonna do? Which one do we want to take? Let's just assume this is gonna be residential area, domestic, for domestic use, communal kitchens. No. We're just gonna assume it's a normal, where you have bedrooms, dormitories, except those in single family dwelling units and hotels and motels. So if it's a hotel, actually you see it's 2.0, so we're just gonna use 2.0. So what we're gonna do is 2.0, right? So 2, and then this is 5, so then this gives us 5 multiplied by 2, and in this case that's 10. So what you're gonna do, this is gonna be 10 and 10 like this, and once you're done like this, you've entered the loads, you're good to go. What is the next step? Go to wind, you don't need to enter anything. Then the next thing you just want to do is go to your deflections. Now check, what are your deflections? Well, when you look at it, it seems as if they're gonna be huge, but actually they're not, because you look at it, the maximum deflection you have is 15.31, and remember our limit is 20 millimeters, so you're good to go. You don't have to worry too much about that. And actually, see, this is the elastic deflection once you are loaded, but then this is when all spans are loaded and you're using the required reinforcement. So check the moments and the shear. This gives you the moments that are carrying throughout that slab strip, right? And the steel, there it goes, it shows you all you want to do, but then you don't have to worry too much. Now you can view this, print it out if you want, and everything. So this gives you an idea. And if you want to do the reinforcement manually, all you want to do is maybe take note of this results, the maximum moment and the maximum shear that is occurring. So what you want to do is, now you want to go to reinforcement, and this is now the critical part that you need to understand. So what do you do at this point? At this point, Prokon tells you it can generate reinforcement for you depending on 5 types. 1 as a normal beam, 2 as a slab, 3 as a flat slab with a column strip, and 4 as a flat slab with a middle strip, and 5 as a rib. So as you can see, where do you get this percentages? So if you want to go to the code, if you see Sigma 3.12 in BS, well, even if you change the code, it will tell you. Let me just change the code, go back to reinforcement, figure 16 and table 17 in Slabs 01 2000. This table, if you want, it's available in Greg Parrot as well, right? If you want to go to Flash Slabs, but it's the same percentage throughout. What it just says is the negative moment, right? Since you're going to have, remember, you have the middle strip and the column strip. So remember, when you're analyzing it in Prokon, this is how the moment, or how you see the moment. So what it is just going to say is, let's, for example, let's pick 1. In this case, the maximum moment at the top at this position it's about negative 253, somewhere about there, right? It's almost, let's just say it's negative 250. So what they're saying is the moment at this point, right, this is what you see in elevation, but in plan, this is what you see. You have the middle strip, the column strip, and then so at this point it's going to be 250, negative 250 million-newtons, right? This is at this point where my mouse is going. So what they're saying is you're going to divide it, that 250, 75% of the 250, or at this point in the middle strip, you're going to see 75 of 250. So let's just put a calculator. So the value they're going to say is 75 multiplied by 250. Okay, sorry, that was 75%. All right, wait, 0.75 multiplied by 250. What is happening? Let me see 0.75 multiplied by 250. This will give you 187.5. So what they're going to use, a moment of 187.5 to calculate the reinforcement that you need in the column strip, and then the reinforcement that you're going to need in the section at this point. What they're going to do is they're going to say 0.25 multiplied by 250. They're going to use a moment of 62.5 to calculate that reinforcement. So that is just basically what. So you are free, if you want, you can change this from negative to positive depending on what you want. Design code of practice. Remember, you can switch BS and SABs. It really doesn't make much of a difference, right? And what is the minimum bar you want to use? In this case, we want to use 12. So these are the minimums we want to use, right? What is the maximum bar diameter? I'm just gonna pick 20 because I want it to be at 20. I don't want it to go beyond 20s. Remember, we have a 250 slab, right? And shrink, we can say 72, but we normally don't use 80 stirrups in this, so we're gonna leave it out. So what is the cover to stirrups at the top? I'm just gonna put 30. Remember, I wanted it to be 30, and I'm just gonna put 30 at the sides as well. And then to the sides, what we can do, 30. Yeah, let's just go with 30. Then what it's gonna do is, once you do this, then what is the span of, because remember, first of all, we need to detail the column strip before we do the middle strip. So for the column strip, because that's where you need the most steel, what you're gonna do is you're just gonna say generate reinforcement, and there you go, you have generated your bars and you're good to go. So in this case, it's telling me one thing I might want to do is, let me just use uniform bars. I want to use 12s, and I'm just going to say the maximum bar is a 12 as well. Maximum bar is a 12 because I want to put 12s. Okay, let me put 12s. Then you say generate reinforcement. So it's telling me I'm going to need 8 Y12s there. Then in this case, I'm going to need 8 Y12s. Then I also need to put 9 Y12s, right? So how are you going to see that? Let's go to the section so that we see that point. You see, this is what it's saying. It is saying at this point, right, you need to put the B. Remember, shape code B. If you go up, this is B. This is B. What I'm going to do, let me just put B over there so that you can have an idea of what I'm saying. This is B, and then so you need 8 Y12s and 9 Y12s. So in this case, if you want, what you can do, just to show you what it is saying, it is saying 17 Y12s at that point. If you want, you can remove this, delete that bar, then renumber the bars, right? This bar, you're just going to delete that bar. Let's delete it and renumber the bars. So it's going to say 17 Y12s on what you need at that point. Remember, this is a very wide beam, so but we'll see if that's feasible. This is saying 17 Y12s, and let's go and check what spacing is that in terms of the bars. So that's 2,500, right, divided by 17. So this is going to be equal to 2,500. This is equal to 2,500. That's a spacing of 147. So effectively, you're going to have Y12s at a spacing of 200, which is, in this case, if you're going to have Y12s at a spacing of 100, that means, that is what, let's see, what was the distance? It was 147. So you can use Y12s at a spacing of 125, which is more than 100. So a vibrator can fit through. So if you want, you can use that white curves at 100. And remember, you're just gonna put this in the column strip. That's where you're gonna use most of this bars, where you're gonna have so many bars like this. So it'll be okay. It'll be okay. All you need to do next is now check for the punch and shear within the slab and see if it's gonna be okay, which is what we will need to do in the next. But now, what I've just done is you've confirmed 7 white curves at 125. This is how it works. So this is how you would do it. This is how you actually design. So in this case, this is what we've done. We have actually designed the column strip for that. And if we want to check what is going to be the one that we need for the middle strip, what you want to do is put 4 and then regenerate reinforcement, and the bars will be overridden. There you go. You have a different set of bars that you're going to put. But in this case, it still seems we're still going to need, even in the middle strip, we are still going to need 17 white curves. But you will understand that if you can see the reinforcement, when we say detail and parameters, and we did it for 3, let me just generate the reinforcement. As you can see, it's different from when I generate the reinforcement and say I am now doing for a middle strip. As you can see, you have more bars at the bottom because there you need to take care of the moments. Because the reason why we're doing this, let me go back and show you. As you can see, the middle strip, the moments, the division, it's more moment is affected for when you have the middle strip, right? It has a bigger moment as well when it comes to the positive, as in the shear, the 45 and the 25. But when the column strip, you need to reinforce the top more than the bottom. But when it goes to the middle strip, you need to reinforce the bottom more than the top. So that is the basis of what you need to do. All right, now let's go back to Prokon. So I think this is it. This is what I'm gonna do. I'm gonna wrap this video up there. Oh, wait before we wrap the video. So what do you do once you've discovered you need 17 bars? The next thing is you want to go to pads where you have it open, and this is where you will need to start placing your rebar. So we will do more about the detailing, and I will now talk about how to detail this part in the next video, which is going to be part 2. So what I'm going to do is let me just end the video right here, then we look at the detailing in the next part of the video, so that we don't cramp too many things into one part. But this is the basis of how you design a flat slab in Prokon. So just remember, let's have a recap. Okay, so just to recap that, what we're gonna do, right, is we're gonna say this is the first flow. What you do is you get your first flow layout, then you establish the midpoints, then you establish the slab strips, then you establish the slab strips in the LX, then you establish the slab strips or isolate the central strip, then you establish the column and middle strip, and take note of your span. And remember, it's a two-way spanning slab in theory. Then the next thing that you want to do is calculate the depth in MathCAD. Then you want to go to Prokon, do the rest of what we have done, and once you have done, you design the program and then you detail it. Then we have to do the process for the whole other slab strip. So which is what we're going to do. We will try and finish this entire slab so that we actually detail it and put the rebar for the entire slab. So thank you very much for tuning in. If this is your first time, please subscribe, and hopefully we keep going through the series as much as. Tell me if you like them, if you don't, and as well, just subscribe, leave a like, and I'll see you in the next video.